Hi class, I am Hong Lei and this is Machine Learning for the Absolute Beginner. Today our discussion topic is dot product, so let's get started. From the algebraic definition perspective, let's think of if we have two vectors x and w, and each of these vectors have d component, x1, x2 to xd, w1, w2 to wd. Okay, this is a convention, so we say x dot w, or the inner product of x and w, or the dot product of x and w is defined to be equal to the first component of x multiplied by the first component of w plus the second component of x multiplied by the second component of w plus dot 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 plus the d component of x multiplied by the d component of w. This long series of expressions can be written in the short form and using the sigma symbol for the summations of x sub I multiplied by w sub I for I from 1 to d. We can shorten it even further, take out the multiplication symbol like this. Now, in the Cartesian coordinate system, we will, let's say, measure the arm length and the leg length. These two axes has to have the same unit. So in this case, we use the same centimeters to measure the arm length and the leg length, and we have the information of two people. We put it here. So we can also express these two data points in terms of vectors, the first vector A and the second vector B. We have A dot B will be equal to the first component of A multiplied by the first component of B plus the second component of A multiplied by the second component value of B. We get the result. So, if we think of x and w as a row matrices, then the dot product of x and w can be thought at the matrix product of the row matrix x multiplied by the transpose of the row matrix w. What this means is that if we have a row matrix w with d components, we transpose it, we'll get the column matrix looking like this. So we have A dot B equal to A, B transpose, and we get the same result. Now, after we have the algebraic definition, we'll talk about the geometric definitions. Why do we need geometric definitions? We have to think from the perspective of the two vectors, okay? The dot product basically telling us how a line, or if there's any angle between the two vectors, and how large is that angle? Is it big or is it small? So the definition is saying that x dot w equal to the magnitude of x multiplied by the magnitude of w multiplied by the cosine of theta, where theta is the angle between vector x and vector w. In terms of vectors, as I said, in Euclidean space, we think of vectors as an arrow with directions and the length, which is the magnitude. With trigonometry knowledge, we know this is a graph of the cosine of any angle x. This x has nothing to do with our x here, because this x represents the angle theta that we are discussing. I want us to focus on this point. Okay, this point expresses that the angle is 90 degrees and the cosine value is 0. What this means is that when the two vectors are orthogonal, meaning the angle shaped by them is 90 degrees, then the cosine is 0. And so we will know that x dot w will be equal to 0 if they are orthogonal. On the other hand, look into the area where the cosine is equal to 1. What it means is that x is equal to 0, meaning that if we have one vector and we have another vector in the same directions, the angle between them is 0 and the cosine is 1. This means that the dot product between those two vectors will be equal to their magnitude multiplied by each other. Think about a vector dot with itself. In Euclidean space, when a vector dot with itself, basically the angle is 0 right? And it will be equal to the magnitude of itself, or multiplied by the same value. This leads us to know that the magnitude of x is equal to the square root of x dot x. And we call this the Euclidean length of vector x, also known as the magnitude of the vectors. Let's think about this particular two vectors that we have on the graph here. We have an angle between them. We call that theta sub 1. Theta 1 is equal to the arccosine of a dot b over the magnitude of a multiplied by the magnitude of b. And just derive directly from this geometric definition of the dot product b. And plug in the number and we will get the result, which will tell us that theta equal to 4.93 degrees. By the way, how this is done, it's just basically a simple lookup. So, all right, thank you so much for watching. I talk to you soon. Bye.